Hi, welcome back. The last video cut me off. Oops! That happens when I run into the 15 minutes. Okay, so again, more pictures, a few more pictures of this mining area. And this is one of those humongous trucks. So you can see this area is a huge amount of area. And yes, they claim to do reclamation, which means they put it back the way it was. But I don't understand how you can haul tons and tons of coal out of someplace and think you can put it back the way it was. If nothing else, it's going to go from a mountain to a ditch. So, but again, unfortunately, we need this. And here's a Suburban compared to one of these tall trucks. And look at the ladder they climb up. I mean, this is like second story kind of thing. These things are huge, and those are the trucks pictured. So, but we need electricity. I'm using electricity to do this PowerPoint. I have let's see, the TV on, a couple lights on, the computer on, you know. I'm drying my clothes. That's electricity. Yeah, I have electricity, not natural gas. So I'm not saying we don't, but I would certainly prefer to have solar panels on my house, but that's me. Okay, again, more pictures of what coal mines look like. And you know, here's the road. Here's the road that those big things, you know, drive. So you know this is a huge area. Okay. So advantages and disadvantages. As I said earlier, it's really important that one of you things you know is advantages and disadvantages, because often you are asked for advantages and disadvantages. I'd say if you know 3 for advantages and 3 disadvantages for each of the things, you're good to go. 2 is okay, but 3 is better. So coal. Advantages. It's very energy dense, especially if you're talking anthracite. There's a lot of energy in a small piece of coal. It's plentiful, at least here in the United States. We have probably a supply that will last us another 200 or plus years. But I don't know if we want to dig up that much space to get it. That's the problem. It's easy to exploit by mining, surface mining. You just blow off the top of a mountain or dig a hole and you can get it. It's very easy to use. There's no serious technology you need to use it. You burn it, create steam, make electricity. It's pretty darn straightforward. It's economically cheap. It's easy to transport because it's a solid. You just throw it on a train. And it needs little refining. There's not much we do to coal. We basically dig it up and burn it. There's not many things you have to do. So it's pretty easy to use. Disadvantages. It contains impurities such as lead, mercury, sulfur, and nitrogen. It will release these impurities to the air. That's how a lot of our mercury and lead and arsenic get into our food chain and stuff, is from burning coal. So there's your trace metals contamination. Combustion can lead to, again, the sulfur and other pollutants, particulates. Little pieces of dirt and dust and ash can get left behind and get into the atmosphere. And of course, burning all the fossil fuels creates CO2, which is a greenhouse gas, and can add to the climate change or global warming. Okay, a little bit about acid mine drainage. The tailings are the rock that is taken off. I'm sorry, let me go yell at my dog again. Okay, I'm back, sorry. Okay, tailings are basically the dirt and rock that is taken off to get, or dug through to get to the coal. A lot of that rock was never kind of supposed to see the light of day. There's some pretty nasty chemicals in our earth, but they don't, you know, they are in our earth and they don't show up. Then they're supposed to be there. But when you dig them up and then leave them for water to run through them, then you can have problems and you can get acid mine drainage. So here's some examples. This is the same area before acid mine drainage and after acid mine drainage. Acid mine drainage usually comes from sulfide. There's other things that can be in it, arsenic and stuff, but it has this classic orangey look, and that's the sulfur. So, you know, so, and the little dots, as they said, those are gulls. Those are birds. So here's all these this is tailings. This is all the rock and stuff, and water is soaked through and basically picked up the sulfur and the arsenic and stuff like that. And that's what gives this kind of that typical orange look in the water. And it will kill. See all these trees on the edge? They're all dead. They're all dead because of this. Animals and plants can't handle high levels of sulfur. So it's pretty wicked. So here's what's supposed to happen basically is you put the tailings behind this, make something so that this can't soak through, and you're supposed to cover it. But if you don't, the water soaks through and either will run right off into the river or it even can get through the river through underground, flow and stuff. So it can be pretty bad. So even though you think they're doing the right things, the contaminations can still get to our lakes and streams. Okay. Moving on from coal. If you have any questions about coal, be sure you ask them in class. Petroleum. This is your gasoline. Okay. Petroleum, oil, same thing. Okay, so it's a mixture of hydrocarbons, water, and sulfur that's contained underground. Oil and gas make the ideal mobile combustions, such as vehicles. Liquid is much easier to burn. Burning coal in your car would be tough. You'd have to be shoveling like they do on the good old-fashioned coal trains or steam trains. So fluids, liquids make better for engines. And so gasoline is fabulous. And diesel is good. Oil formed, petroleum formed from ocean-dwelling phytoplankton, that is plants, 50 to 150 million years ago. It was under compression and stuff and formed your petroleum. The countries with the most petroleum, of course, Saudi Arabia, Russia, the United States, Iran, China, Canada, and Mexico. And we, even though they don't have a large supply, we get a lot of our petroleum from Venezuela. And so Saudi Arabia and that area, Venezuela, they have a lot of control over us because we need more petroleum than we produce. And that can be a problem because they can kind of decide how much they want to make us spend and stuff, which is why I do not understand how our gas prices have really dropped. They used to be over almost $4, and now they've dropped back down a while back, and they dropped quite a bit and stuff. So somebody's playing with our gas prices because the law of supply and demand, supply is just going down and demand is increasing, so that means the price should go up, and it's not really the way it is. It's kind of fluctuating, which is really odd. Somebody's playing with it. Okay, OPEC. OPEC. Hopefully you've heard of OPEC before. This is the Organization of Petroleum Exporting Countries. There's 13 countries, and they have 67% of the world's reserves. The countries are listed there, as you can see. And you can see the United States is not one of them. Or important other producers, Alaska, Siberia, and Mexico. So there you go. So OPEC. So basically what that was, it's a bunch of countries are banding together to control prices and getting as much as they can for the money, for the research, which they should really. So when we harvest petroleum, we usually drill down and stuff, and usually there's a little natural gas, which is CH4, methane primarily, with it as well. And of course now we try to gather that methane and contain it as well for use rather than using it. Okay, advantages of petroleum. It's very easy to transport and use. We can put it in tankers. Gas stations are very easy to use. It's easy to transport in our cars and keep in our cars for using. It's relatively energy dense. There's quite a bit of energy in a gallon of gas. It can get you, you can get your car 20 miles down the road kind of thing. That's pretty good. It's cleaner than coal. It has less contaminants and stuff, so it burns cleaner than coal. But disadvantages, of course, is it still releases carbon dioxide, which is a greenhouse gas. If you have leaks, if you have an oil spill, anything like that, it can be highly damaging to the environment. So there's always a risk of spills, both in extraction, transporting, and even later on in gas stations and stuff like that. A lot of gas station tanks under gas stations leak which is why actually here in the United States, all the gas station tanks had gone from just kind of a tank in the ground to they have to be double hulled, which means there's a tank within the tank. And so that if the inner tank ruptures, the outer tank will still contain the gasoline. That didn't used to be true, and the tanks would rupture and slowly leak gasoline into the surrounding soil. So that's why you see sometimes a lot of abandoned gas stations, because when they had to go from a single tank to a tank within a tank, a lot of the gas stations couldn't afford to have their tanks pulled out and redone and new tanks put in, and so they just went out of business. So that's why a lot of them, a lot of places are out of business. Okay. Also, another disadvantage, of course, is it still, even though it releases less than coal, it still releases sulfur, mercury, lead, and arsenic to our atmosphere when it's burned, as well as nitrogen, which we'll talk about. Okay, so moving on to natural gas. Natural gas is primary methane, but it has some other gases in it with it, such as ethane, propane, and butane. All natural gases due to decomposition kind of stuff, which is why our landfills and stuff like that also produce methane. Actually, cows and stuff produce methane. Anything when the breakdown of food will produce methane. So, okay. So advantages. It contains few impurities compared to your other fossil fuels. There's very little or no sulfur and very little particulate matter. When you burn it, it burns pretty darn clean. It only emits 20 or 60% of the same amount of carbon dioxide as coal, so even less CO2 emissions using natural gas. Natural gas does not have to be processed. It's basically gathered and can be used. It is hard to transport, and it's kind of dangerous because we have to use it through pipes and stuff. But, you know, occasionally you can have gas leaks and stuff in homes, so that can be dangerous. So that's always a problem. Methane is a major greenhouse gas. So if it escapes, you are adding a greenhouse gas. Like when you first turn on your stove and it hasn't quite clicked on yet and started, a little bit of it will escape. And so that's a greenhouse gas. There is potential for contamination of groundwater. We will talk about that more and look at that more when we talk about fracking. Which is the newfangled way to go after natural gas. And I guess we should watch Gasland. Forgot about that. So we'll be watching a movie about fracking, talking about fracking in class. And of course, even though it releases less CO2 than coal, it still releases CO2 to the atmosphere. And CO2 is a greenhouse gas, and climate change can lower biodiversity. Okay. So then there are other types of fossil fuels. Oil sands is a deposit of bitumen, which is kind of a liquidy coal, if you will. It's usually mixed with sand, water, and clay, so it has to be removed. Up until recently, it wasn't feasible to use oil sands. Because it costs too much to isolate the bitumen from the sand and clay and water and stuff like that. But that has changed, and we're starting to use this more because there's a better price, although it's not occurring at our gas station, that's for sure. But as the price of as the price of gasoline goes up, it becomes more feasible to spend more money to gather these other types of fossil fuels. So you'll see them more and more. Bitumen is kind of a pitchy kind of petroleum. It's a little bit more liquid, sticky kind of thing. There's also tar sands and some others that you should be aware of. Okay. Energy use, per capita energy use is pretty much staying the same. Per GDP for gross domestic product, it's going down a little, which is kind of good. Okay, I'm going to stop there. No, wait a minute. Hubert cycle, we'll talk about in class, read about it. Oh, yeah, I can't get through these. Okay, one more short thing to go. Bye.